In this lesson, we will discuss k-medians and k-modes clustering methods. We will start with k-medians, which handles the outliers issue in k-means by computing the medians. After that, we will go over k-modes, which clusters categorical data. The key idea in k-medians is that it replaces the mean, which is sensitive to outliers, with the median, which is much more robust. The median corresponds to the 50th percentile, so even if some values are extremely high or extremely low, the median tends to stay stable. Think about clustering the salaries in a company. Usually, the top earners are going to skew the mean, but the median tends to stay stable. In k-medians, we are building on the same idea, and we use the median as representative value. The k-medians algorithm itself follows the same iterative process. First, it selects k-points as initial representative objects, which are the k-medians. After that, each point is going to join its nearest cluster, then recompute the median using the median of each individual feature in the feature vector, and repeat the process until the convergence criteria is satisfied, which is the cluster is stable and the median is not moving. Moving to clustering categorical data, a traditional distance measures such as L1 distance or cosine similarity do not work, because simply mapping categories to values like 1 and 0 is going to generate low-quality clusters. Remember, now the distance does not carry any magnitude information, so we don't really know how far or how close these data points from the centers, because the distance is based on a mapping that may or may not capture this magnitude relationship. To solve this problem, k-modes replaces the means with the modes, which are the points that appear the most in a dataset. And for the dissimilarity measure, it's going to define a measure that is frequency-based. Here's a simple example. Suppose two objects are different, then we are going to assign a value like 1, otherwise it's 0. This is a very simple definition. It can be more involved to capture the variation of the categories in the dataset. Here's a simple example. Suppose we have a cars dataset that consists of 5 examples. We picked example 2 and 3 as centroids, applied the distance measure. We found that example 1 is closer to C1, example 5 is closer to C2, example 4 has the same distance between the two centers, so we can assign it arbitrarily. To summarize what goes inside the k-modes, the dissimilarity measure is frequency-based. The algorithm itself does not change. It's going to find the initial centroids, compute distances, find initial clustering, then iteratively improve the clustering until it converges. There are variations of the k-modes idea. A fuzzy k-modes is going to use a fuzzy cluster membership value, which means each data point is going to have something called membership degree value between 0 and 1 that describe how close it's from each centroid. Another method is called k-prototype, which mixes the categorical and numerical data. In summary, we discussed the k-medians and the k-modes clustering methods.